When a computer is running and executing computations, it's also generating waste heat. Modern computers have immense numbers of transistors or switches concentrated in a very small space on the processor that are operating at very high speeds. It's not surprising to imagine that the electrical paths will be in frequent use, moving electrons and generating heat due to electrical path resistance. However, what might be surprising is that even if you could optimize these processes and reduce or eliminate these heat sources, the computer would still generate lost heat. But why? It's actually due to lost information. If you take a basic computational task, like adding two numbers like 5 and 10, you'd get 15. However, if you try to figure out what values were added to get 15, you wouldn't know. It could have been 9 and 6 or 11 and 4. This process is not logically reversible. Information has been lost, and necessarily there must be an increase in entropy as lost heat. The simplest possible erasure of information happens at the bit level. The loss of a single bit of information results in an increase in entropy of at least K2, or 10 to the power of minus 23 joules per Kelvin per bit. These erasures happen in many parts of a computer, but consider a basic OR logic gate. Its output will be 1 if any or both of its inputs are 1. So there are 3 situations where it can produce a 1 output. And we couldn't tell which it is by knowing just the output value. It's not reversible, and information is lost, and entropy goes up. Interestingly, it turns out that it can be proved that all computer operations can, in theory, be made to be reversible so that no information is lost. The only exception is erasure. It is possible to construct logic gates that are reversible and will not suffer from information loss and hence heat loss. This can happen by making sure that you can determine the inputs going backwards from the output information. You'd need to ensure that the outputs of a gate match the number of inputs to prevent information loss. Yet there is also a cost to doing this too. You don't waste heat anymore, but now you're wasting information, since you have extra outputs that you don't need. And again, if you want to get rid of that information, you'll have to pay the price of added entropy when you erase it.